Hi class, this is Ms. Schwans, and I'm making this video for 2.1. We're starting chapter 2. In chapter 1, we learned about different voting methods, and in chapter 2, we're moving on to weighted voting systems. The main difference is that in chapter 1, usually one person was given only one vote, and that's typical of our presidential election. However, if you think about the Electoral College, actually each state has, based on the amount of people they have in the state, a certain number of Electoral College votes. So I believe California has, I can't remember how much they had in the last election. It was like 52 or something, and then Oregon had 6 or something like that. So because Oregon has a quite smaller population, right? So the Electoral College is an example of a weighted voting system where each state has more votes or less votes based on their population. So chapter 2 will be dealing with weighted voting systems like the Electoral College. There are notes that you can print out or just download and keep on your computer while you're watching this lecture. So there's a link underneath the video here if you want to pause the video and then print the notes and then follow along and write your notes as I do this lecture. You may. So we're going to, there, how much weight or number of votes are controlled by a particular voter will, so each voter or each player, we're going to call them player in this situation, so how much weight does each player have? And we're also going to be thinking about how much power over the election, over the outcome of an election that a player has. When each voter, of course, has a different number of votes or different weight they carry. So, like I already mentioned, examples are the US presidential election by Electoral College. Each state has a different number of votes based on the population size. Regional and local government, I guess those elections also have weighted votes, voting systems. And then country boards, where large districts have more votes than small districts. And United States and United Nations Security Council, some countries have veto power and others don't. And corporate shareholders. So I don't know if you own these shares in a company or any stocks. If there's like if they break a company into 1,000 different pieces and you're allowed to buy so many of those shares, or then you're giving voting power, or if you want, I won't say voting power, but you're giving the amount of votes as you have shares. So it's a weighted voting system of a company. So in 2.1, there's an introduction to weighted voting. And really here I want you guys to understand some of the definitions of the words and the notation that we're going to be using. So a weighted voting system describes any formal voting arrangement in which voters are not necessarily equal in terms of the number of votes they control. We will focus on yes-no voting. So we're not going to be voting for different candidates. It's just like the situations in which mostly likely happens in a company. Are we going to merge with another company or not? Like, would they need to make a big decision, or they just need a yes/no answer? So that's the type of voting that we're going to be talking about. U.S. presidential elections and by Electoral College, regional, those are examples of, a lot of times where yes/no voting is used, like, are we going to vote for a certain measure or not? It's yes/no. Okay. 3 common elements of a weighted voting system. instead of calling them the voters, we call them the players. So we will call the person player number 1, player number 2, player number 3, and player number 4. They might be like the different states. They hold their each different weight. And the weights that go with each player are W1, W2, and last player just they call WN, when N is the number of players. So notice here that when we say W1, we're not saying W subscript 1 here. We are not saying, take the variable 1. So this is W subscript 1. We're not saying take the variable W and multiply it by 1. No, we're instead of using another letter like X, we're calling it W2, W subscript 2. So it's just another way of coming up with a different variable. Instead of coming up with a different letter, we just say W sub 1, then W sub 2, but that's just naming the variable, okay? All right, and then the last thing that's important is a quota. A quota is how many votes need to be met in order to pass a motion. So maybe, are we going to spend a lot of money on fixing up Fresno State? Okay. There's certain, they set this, if we get so many votes, then we're going to go ahead and say yes on that motion, and we're going to, provide more money to fix up Fresno State. So you can't make any decisions unless you meet the quota, either yes or no. A generic weighted voting system within players can be written as this. So this is the notation they like to use. They like to use these square brackets, and the first number in square brackets is just accepted as the Q, the quota. Then they use two little dots, and then they list out the weights of each player. So it's going to look like what we see below. See how it has the square bracket 10, 10, 8, 5, 3, and 2. So let me show you this with an example. So this example 1, 4 partners decided to start a business. In order to come up with the $150,000 needed to start their business, they sold $10,000 shares. So they were given a voted weighting based on the number of shares that they purchased. So if they purchased 8 shares and each share was a $10,000, 8 times 10,000 is $80,000 that they invested in the company. So they paid $80,000, and they're going to, because that they paid for 8 shares, they're going to get 8 votes. Like they're worth 8 people. Their one vote as one person is worth 8 people, because that's the amount of money that they invested in a company. And it's fair because they invested more money. They have, more to lose than other people that are in this, right? So their voice and their say on matters should weigh heavier because they have more at risk, right? So then this person, then someone else bought 5 shares, 50,000. They bought 5 shares, paid $50,000 for them, and they have a weighting vote of 5. And then another person bought 3 shares, paid $30,000 for them, and they have a weighted vote of 3. And then the last person paid for 2 shares, paid $20,000, and they have a weighted vote. Their weight for voting is 2. So this is what it looks like. So looking from above, and after the square bracket, you have the quota. So 10 is your quota in this voting system. They decided in order to make any decisions, we have to have 10 votes for that choice, whether yes or no. And then the first person in this weighting player, which they call player, in this weighted voting system has a value of 8 votes. The second person has a weight, they call it the weight of 5 votes. The third person has a weight of 3 votes, and the last person has a weight of 2 votes. So we can fill this in here. Blank is the minimum number of votes to pass a motion. So that's 10. And it's also the Q. That's the notation for it. Blank is the weight of the player 1. So 8 is the weight of in front. We're reading this voting system right here, weighted voting system. And so 8 is the weight of player 1, and 5 is the weight of player 2, and 3 is the weight of player 4, 3, and then 2 is the weight of player 4. Okay, because the first voter has 8 votes, and the second voter, the second player here has 5 votes. Third player has 3 votes, and the fourth player has 2 votes. What does the weighting vote system, so let's look at the second example. What does this weighted voting system tell you? So we look at this picture, we see the square brackets, we see a number first, and then dots, and then followed by other numbers with commas. So it tells us that the quota is 15, right? So let's put that in there. I think I put a text box in. I could remember how to do that really quickly. Or maybe I can't. Okay. I'll just write it. Okay, the quota is 15. What else does it tell us? It tells us the weight of player 1 is 9. Right? So from this number right here, okay, then the weight of player 2 is 6. And then I'm just put quotation marks here, the same as above. The weight of player 3 is 4. Then what else does it tell us? We could find the total number of votes in the voting system if we added them all together. So the total number of votes in this system is equal to all of the weights added together. So it's 9 plus 6 plus 4. Plus 6 plus 4 is 10, plus 9 is 19. So there's a total number of 19 votes in this voting system. And then, so that makes the quota is 15 out of 19. That's the fraction needed to pass a motion. So I just took Q and put it over which is Q, the quota, over all of the total votes, and that's the fraction of the total votes that you need to pass a motion. So that's an interesting number because you'll see that sometimes, depending on this, I guess, the importance of decision, they can change the quota and they can make it. A common one is half. You have to meet half or of the votes. I'm sorry, or usually as more than half. Usually they want the majority, right? More than half. So it's important for us to know what half of the total votes is. And then also sometimes a common one is 2/3. And if you from your government class, a lot of times 2/3 of the votes are needed in certain situations. I think it's like, you'll have to go look into your history class and figure out, where do we need 2/3 of a vote? I think it's to pass an amendment or something like that. Okay, but I'm not going to say. I'm not sure. You have to look back in your history, your government class. Okay. Total votes. Okay. In the weighting voting system, Q, so they don't give us the quota here as a number like we saw above. They give us just a Q in place of the number, so the Q is unknown. And then at this moment, then they say the weight of the first player is 10, the weight of the second player is 8, and the weight of the third player is 5. They say, what is the quota if a strict majority of votes are required to pass a motion? So a strict majority is more than half. So first we have to figure out what is half of the total votes. And once we find half, we're going to add 1 to that. So the majority is more than half. So there's 10 plus 8 is 18 plus 3 is 23. So I find the total votes. That's 10 plus 8 plus 5, which is 23, and then half of 23. So you can divide by 2 or you can multiply by 0.5. So I'm going to divide by 2. 23 divided by 2. Oh dear, so 22 divided by 2 would have been 11. So it's 11.5, which we would round up to 12. We can't have like a partial vote, right? So 12 would be more than the majority. So our quota here, if we set the quota to be a majority, which is more than half, it would be 12. What if the quota is 2/3 of the votes required to pass? So we just need to find what is 2/3 of 23. So I just say 12 would have to be the quota. If the quota had to be a majority. Okay, what is 2/3 of 23, since that 23 is the total number of votes? So remember the O in the of is a multiplication dot. So it tells me to multiply 2/3 times by 23. Now I could put as a 1 underneath the 23 to turn it into a fraction. And then now I can just multiply straight across. So that's how we multiply fractions, is multiplying the numerators together. So 2 times 23 is 46. And then 3 times 1, I multiply the denominators together, is 3. And now in my calculator, I can just do 46 divided by 3. Since this fraction, 46 over 3, is an indicated division. now we can just do that calculation. And I can't, and you could just use that, do that on your calculator. Just gonna I get 15.333. So of course we have to round that up because if we rounded it down to 15, 15 would not be 2/3 the vote, it'd be a little bit less. And of course we can't have a partial vote, so I would round this up to 16. Even though with the general rule for rounding is you look at the 10, well, if you're rounding the whole number, you look at the tens place. If it's greater than 5, we would round up, and if it was greater than or equal to 5, we would round up. If it was less than 5, then you would round down. However, I can't round down here because if I round down, it's less than 2/3 of the vote, so I have to round up to 16. So okay, so the quota would be 16. So 16 would be the quota if the quota had to be 2/3 of the total. Consider the Western United States in the U.S. in the House of Representatives: California, Washington, Oregon, Nevada. Their weighted voting system would be Q. So they're again Q. They're just letting a letter be there. The Q. They're not putting a number for us yet. And then 52 must be California. 10 is Washington, and 6 is Oregon, and 4 is Nevada. What is the quota if a majority of the votes are required to pass? So again, we need to just find the total number of votes and then take half of that and then add 1. So 52, and they like to use a capital letter V for the total number of votes. So 52. Just write total votes. Plus 10, plus 6, plus 4. So that's 62, 68, 72, right? And let's try to do this in a second in a different way. So 6 plus 4 would be 10, plus another 10 would be 20, but 20 plus 52 would be 72. So that looks right. And then we can figure out what is half of 72. So 72 over 2, or 72 times by 0.5 would be 36. So add 1. If it was a decimal, you would have added, whenever you're trying to find the majority, you find half, and then if it's a decimal, you just round up. If it's a whole number, then you add 1. So it's 37 would be the quota. What is the quota if 75% of the votes are required to pass a motion? So I have to find out what is 75% of 72. So I would do, sometimes I write the question out and it helps me figure out how to do it. So remember the O and the of looks like a multiplication dot. So I turn 75 to a percent. I'm sorry, return the percent to a decimal by moving it twice to the decimal, twice to the left. So it's 0. I'm going to put a 0 here, but the 0 is not important, right? But we just write it so that it's emphasizing the decimal point there, times 72. So 0.75 times 72, what is that? Luckily, in this class, you guys get to use your calculator for the test, so you do not have to calculate this by hand, but it's 54. If this was a decimal answer, I would have rounded up, but since it's not, I'm just gonna go ahead and leave it as is. With majority, because majority means more than 50%, you have to add 1. So we added 1 to the 36 above. But here it's just 75%. So 75% of the votes would be 54. 54 is sufficient to pass a motion. So 54 is the quota. Okay. What is the quota if an unanimous vote is required to pass a motion? Unanimous means everybody has to agree on it. Everybody has to say yes on it. So that would just mean that all 72 people would have to vote yes, so or whatever, or the same. So 72 would be the quota. What is wrong with referring to a player in 10, 5 in this voting system, 10, 5, 5, 3 as player 5? So if I had this voting system, if I was calling this first player that has 5 votes, player 5, which is a mistake that some students make, the problem there is that actually there's another player, player 2, that also has, 5 votes. So we would get confused between who is player 5, right? So that's why we have the notation the way we do. So we have to keep, this would be player 1 is this first 5 here, and player 2 would be the second 5. Wait, we have a weight of the second 5 here. Okay, and then player 3 would have actually 3 votes here. So we don't want to name the players after the weights they have. What's wrong with this voting method, this voting situation? So you have a quota that's 4, and then you have the first player has a weight of 3, the second player has a weight of 2, the third player has a weight of 4, and the fourth player has a weight of 2. So let's say they're voting on some kind of measure. Let's say that the first 2 people vote yes. I'll put a Y and a Y next to them. And then the second 2 people vote no. Well, we would count the number of votes for yes, that would be 5. You would meet the quota, so you would say, hey, well, we need to do whatever these 5 people say, to do. Not 5 people, but 5, these 2 voters that had their votes add to 5, a weight of 5. We need to go ahead and say yes on this measure, but then we count the number of no votes. Is number of yes votes is 5, and then we count the number of no votes. Like I said, if the last 2 players here, player 3 and player 4 both voted no, then that would mean a total of 4 plus 2, which is 6 no votes. So what's happening is both sides are meeting the minimum 4 requirement to pass the motion. So technically both of them should have their way, but we can't have everyone have their way. We can't say no about something, a decision that needs to be made, and also yes. But so what's happening is both the yes group and the no group are both meeting the minimum requirement to pass to have a decision be made. and they have conflicting decisions. So what's happening here is they call it anarchy. Everybody is just getting their way. And that can't happen. So because we need to make a decision at the end of the day. We can't have a tie here. We're like, oh, we don't know what to do. So what they say is the quota should always be more than the majority of the votes. That's what's happening here. This quota of 4 is so small that both sides can easily meet that quota. We need to make the quota more than half, so it forces, either the yes votes are going to win or the no votes are going to win. Okay, so there's not anarchy. So I wrote down here, the quota must be more than half, which is a majority of the votes. More than half is the same as the same majority, right? And then let's look at what's wrong with this voting system. So the quota is 10, so it's 10, and then the first weighted voter has 1 point. The second has, the first player has a weight of 1 point. The second player has a weight of 1 point, and the third player has a weight of 2 points. So if the first player votes yes on a motion and the second player votes yes and the third player votes yes, then we add up all of their votes, number of votes for yes. It's 1 plus 1 plus 2. Well, that's 4, and that's not enough to pass any motions. So what's happening is this quota is way too high and compared to the total amount of votes in this system. So nothing is ever going to be passed because the players together don't have enough voting points to meet the quota in any situation. So nothing is going to get done. So this is called a gridlock. And what's happening here is the quota is too big. So the total number of votes, okay, so the quota can't be too small. That's what happened in this situation, quota too small. And we had anarchy. Everybody got their choice, their way. And this example is your quota is too big. Nobody is going to get their way. So we have to put, we have to put limits on and minimums, a minimum and a maximum on the quota. So we say it has to be more than half the total votes, and it also has to be less than or equal to the total amount of votes. And this is what mathematically, if you let V be the total number of the sum of all the weights in a voting system, which I call the total number of votes, then it has to be greater than half and less than or equal to the total number of votes. All right. We just have a few more definitions in this section, and then we'll be done. But names of special players in a weighted voting system. A dictator is a player who can pass a motion on their own. So let's consider this weighted voting system. 20 is a quota, so you have to have 20 votes in order to pass a motion. The first player has 21 votes. The second player 8, and the third player has 7. So no matter what this first player says, it goes because he has enough votes to pass the motion just by voting by himself. So this player right here, player number 1, is the dictator. Because 21 is greater than the quota. His weight, player 1, is a dictator. because player one's weight, which is denoted W sub 1, is greater than the quota, which is denoted by the Q. All right, and then they talk about veto power next. A player who can keep everyone else from passing a motion if they vote no and everyone else votes yes, is called a player with veto power. So what we're going to do is we're going to cover a player's votes. If the remaining votes are less than the quota, the covered player has veto power. So let's consider the voted weighting system. The quota is 10. The way player one has four votes, a weight of 4. Player 2 has a weight of 3. Player 3 has a weight of 3. And player 4 has a weight of 2. Did I say that right? Okay. Anyways, we cover up. I always start when I do this, I start with the highest level. If anybody has voting veto power, it's going to be the ones with the highest amount of points. So I cover up 4 and I add, I'm like, if 4 votes no on something, if all these other people vote yes, we would add all their votes together. So it'd be 3 plus 3 would be 6 plus 2, which would be 8. So does everyone else have enough power to pass the motion without player 1? So the answer is no, because 3 plus 3 plus 2 is equal to 8 and it's less than 10. So even if all these people ganged up together and voted together on something, they still could not get a motion passed with that one person saying no to it. It like makes it not pass. So we would say that this player 1 has veto power. Let's check and see if player 2 also has veto power. So I cover up player 2 and I add 4 plus 3 plus 2. So that 4 plus 3 is 7 plus 2 is 9, and it does not equal the quota. So player 2 also has veto power, because if he does not vote, then for something, for something, then the rest of everybody else can't make it pass without that one person. So he does have veto power. So player 2 also has veto power. And that would be, since player 3 has the same amount, like player 3 will also have veto power. Let's look at player 4. If I cover player 4, then the votes are 4 plus 3 plus 3. So that's 7 plus 3, that is 10. So player 4 does not have veto power because players 1, 2, and 3, their numbers add together to 10, so they can pass something without player 4 also agreeing with them. Okay, so that's veto power. And then they ask us, in each of these situations, does any have veto power? So like I said, if anybody's going to have veto power, it's going to be the top most weighted player. So I cover 4 and I add 3 plus 3 plus 2. So let's say player 4 votes no. Does the rest of the votes have enough power? If they all vote yes, do they have enough power to pass the motion? So 3 plus 3 is 6, plus 2 is 8. They will not have enough power. They need player 1. So player 1 does have veto power. All right, let's cover player 2's points, and let's see if they vote no on something, and everybody else votes yes, then you'd have 4 plus 3, which is 7 plus 2, which is 9. So they do have enough power. 4 plus 3 plus 2 is 9 or greater. It does meet the quota. So this player 2 does not have veto power. Everybody else, if they voted yes and player 2 voted no, it would not stop the thing from passing, right? They can pass it without player 2. So he does not have veto power. And we can check, but I took away somebody with 3 points, right? 3 points. That means if I took away somebody with less points, there would be more points for the opposing side. So if I took away 2 or this one because he had the same amount of points, or this one because he has less points, they would not have veto power because we already determined somebody with 3 points. If you take away 3 points from the total, that they don't have veto power. So anybody with lesser power is not going to have veto power either. So we don't really have to check the rest. But if you wanted, you could. You could say, okay, if we take away 2, would they have at least 9 points? So it'd be 3 plus 3 is 6, plus 4 is 10. So they definitely would have enough points to pass. So okay, that's just a shortcut. Let's look at the next thing. So the quota here in B, example 8, part B, is 7. So like I said, check the person with the most points first. I take away player 1, and I see, does everybody else have enough points to pass the motion? So if this one said no, and all these people said yes, could we pass the motion? So 3 plus 3 is 6, plus 2 is 8. Yes, we would have enough to pass the motion without player 1. So player 1 does not have veto power. So if we took away a smaller number, the way I think about it is, the worst case scenario is the highest person, the highest weighted person votes against you. Does the rest of the small people have enough to pass them? If yes, they do, then if you took away a smaller number, they are still going to have enough power to pass. So let's any motion. So I don't think if the highest weighted person doesn't have veto power, then anybody else smaller will not. So let's just see that. So if I take away the 3, then 4 plus 3 is 7, plus 2, they already met. So they can definitely pass any motion without player 3. So with player 2. I'm making the same. Okay, then with player 3, the same thing, right? They're going to have 4 plus 3 plus 2, so it's 7 plus 2, so 9. They're going to have power to pass a motion. And the same thing with, if I take away player 4 here, then I have 4 plus 3 plus 3, which is 10, which is definitely enough to is bigger than 7, so it's enough to pass motion. So nobody here has veto power. All right, let's see the last example. Like I said, if anybody has the veto power, it's probably the highest weighted player. So let's take away player number 1. If player number 1 votes no, can everybody else pass the motion without player 1? That's the question. So 3 plus 3 plus 2 would have been 6 plus 2 is 8, which is not enough. So they need player 1 to pass the motion. So player 1 does have veto power. Okay, let's see if player 2 has veto power. So if I cover him and then do 4 plus 3 is 7, plus 2 is 9, we still don't have enough power. So player 2 is also a veto power person. And player 3, because they have the same amount of points. And player 2, let's see if I take away player 2, then you have 4 plus 6, which is 10. So you do need player 2 as well. So, or player 4, I'm sorry. So you do need all 4 of these players here. They all 4 have veto power. So basically, here is an example where it has to be unanimous. Everybody has to vote the same way to get something passed. How much power does each player have over the outcome of a motion? So we kind of saw back there that I would say when somebody has veto power, that gives them more power than other people. And we'll see 2 methods for calculating the power of players in this. And the first method for calculating how much power, that means how much power do they have to alter the results of an election, right? That is that we can calculate that power using Banzhaf's power distribution in section 2.2. We'll learn about that method. And then a second method, another way to calculate power, is the Shapley-Shubik power distribution, and that's 2.3. All right. Thanks for listening. Hope this helped you. Have a great day. Bye.